Welcome to the first lesson on my structured cabling lecture series. This is a YouTube course designed to help you learn structured cabling standards and techniques. I will cover fundamental technical concepts to advanced concepts as we progress through these lectures. For associated lectures, please check the link to the course playlist in the description of this video. This is our first lesson, and today I will introduce you to cabling standards and how we come about it. Before we go into structured cabling, let's learn what is structured cabling. Structured cabling came about as the telecommunication and information technology progressed through time. It was first actually introduced as a method of standardizing certain cabling standards for telecommunication systems, mostly by AT&T and Bell Laboratories, but later become a part of also networking infrastructure and information technology industry. Structured cabling is also associated with standardized subsystems and elements so that we can keep everything in groups and in certain categories. And those standard elements and subsystems are part of the wider system we call structured cabling. As we progress through this course, as I mentioned before, you will learn about how they are different and what I meant by subsystems and standardizations. Structured cabling also involves design, installation, and management of cable media and associated devices. Those include the patch panels, optical cabling, twisted pair, etc., etc. For example, what kind of crimping standard you're going to use on a twisted pair is based on how we define the structured cabling standards we use today. So you don't just go around and just create a twisted pair. You follow a certain specific standard, and that has to do with how we define the structured cabling standards. Cabling specialists, network technicians, engineers, and even management professionals use these standards to make sure that all the equipment within a network, and whether an IT infrastructure network or whether it's a local network, that they're gonna use those standards to make sure that everything works smoothly. So what is structured cabling? So structured cabling is a methodology or standardization of how we manage the cable media, or such as the optical fiber or fiber optic cables, the twisted pairs, patch panels, etc., etc., in communication systems. And it first started with the telecommunication industry, but now it is also part of the information technology industry as we progress through time. So if somebody asks you what is structured cabling, these couple of bullet points, these 4 bullet points will exactly define what is structured cabling and what it means for IT technicians. So we quickly, briefly describe, what is a subsystem, like, how subsystem are important to structured cabling. In IT industry and telecommunication industry, what really, important here is that you understand that we have these 5 subsystems. Those are called entrance facilities, equipment rooms, backbone cabling, horizontal cabling, and networking rooms or enclosures. These are 5 major subsystems that we use to define structured cabling in information technology industry. So entrance facilities is basically the point where the telephone company network ends and connects with the on-premise wiring belonging to the customer. In other words, the entrance facilities, such as in this diagram, the entrance facility is going to be the facility where the responsibilities of the telephone company or the networking company or the ISP ends and get handed over to the whatever the other organization responsible for the customer, whether it's a customer themselves or it could be another third party. The equipment rooms house equipment and wiring consolidation points that will serve the user inside that building or a designated area called campus. So if you have watched my previous lectures and lecture series on CCNA and even CCNP and other courses, I have used the term campus multiple times. What campus basically means is a designated area that the customer is responsible for. So equipment rooms are part of that area, so it houses the equipment and wiring points where that the customer is responsible for, and that equipment room can be a part of one single building, or that equipment could be a part of a entire large facility or complex of facilities, such as a university or a small building complex with multiple buildings connecting to each other. The backbone cabling is the inter-building or intra-building cable connections in structured cabling between entrance facilities, equipment rooms, and telecommunication closets. In other words, the backbone cabling consists of transmission media, main and intermediate cross connects, and transmission systems or facilities at this level. So the system is mostly used in data centers. So the term backbone cabling, most likely you're going to hear if you're going to work in a data center or with an ISP. So if you work for an ISP, you will hear the term backbone cabling. What it basically doing is connecting between multiple sites. That would be the backbone. That's where the term backbone comes from, of the entire network infrastructure. So it allows the intra-building and inter-building cable connections with very high bandwidth, availability, redundancy, and a lot of other stuff going in here to make sure that the entire network is resilient and can handle the customer's needs. So that's what the backbone cabling is doing. So typically, as I mentioned, backbone cabling is found within ISPs, from ISP site to ISP site, or between ISP facility to facility building to ISP facility building. So for example, Shaw Cable in Canada, for example, could have, or Rogers, for example, could have 2 Rogers buildings nearby with the networking and data infrastructure, and the connection points between those 2 buildings going to be that backbone cabling infrastructure. But at the meantime, the Rogers and Shaw Cable also provide backbone infrastructure to different various neighborhoods. Like for example, each neighborhoods in Calgary, Canada would have backbone cabling infrastructure going into those neighborhoods, whether it's residential facilities or whether it's a commercial facilities. And those infrastructure that goes in, like for example, fiber optic cables that goes all the way into toward the neighborhood box before it being distributed, would be considered as part of the backbone cabling. So basically that defined the backbone of the entire network infrastructure. The next one is the horizontal cabling, which are basically wiring that can be standard inside like inside wiring. So it includes the planar cabling, connects telecommunication rooms or networking rooms to individual outlets or work areas on the floor. So usually through wireways or conduits or ceiling spaces, wherever the cabling is going in, that's where the horizontal cabling coming into play. And in this course, I will focus a little bit more heavily towards the horizontal cabling aspects of structured cabling subsystems, because that's where most of the IT technicians like yourself would be working on. So horizontal cabling basically define the area where you pull cables through for your customers inside a building or in customers' premises. The networking rooms and the enclosures basically connects between the backbone cabling and the horizontal cabling. So this guy basically sit between the backbone cabling and the horizontal cabling. The networking rooms and enclosures will sit in between. As a network technician, it is most likely your responsibility to manage those networking rooms and enclosures, because it's part of the inside facility items. So what they basically do, they're going to connect between the backbone cabling and the horizontal cabling, and the work area components connect the user equipment to the outlets and in the horizontal cabling side of things. So basically these networking rooms are basically in between mediator kind of thing, it was sitting in between the backbone cabling and the horizontal cabling. So as I mentioned, for most IT technicians in the industry, it will be working between these horizontal cabling subsystem and the networking rooms and enclosure subsystem. So I will be focusing a lot of my material on these two items, but I will also cover some entrance facility, equipment rooms, and backbone related items as we progress through this course. So on the right hand side, we have a diagram I pulled from Wikipedia, and it shows the horizontal cabling in work area. So if the end user is sitting in front of a computer and accessing the network, the end user all the way to the patch panel is basically considered as a horizontal cabling. But starting from the patch panel to the switches and routers and networking equipment, that would be the telecommunication enclosures, and those telecommunication enclosures eventually going to get connected to the backbone, which is your ISP, for example, and that backbone cabling happening between your home or a business or enterprise switch or a router and the core switches and the routers that the ISP is responsible for. And then the ISP would have their own infrastructure within their equipment rooms, and that's how we defined the subsystems of the structured cabling methodology. So again, I will go into a little bit in depth of subsystems later on a later lecture, but we're going to a little bit focus more towards history and cabling standards for the next few slides. So let's look at the history. In 1837, Samuel Morse created the first telegraph in USA, and that would be the first stepping stone in how structured cabling came about. Before that, there were cabling systems, but there was not very well defined. But as the Morse first started the use of telegraph, the commercial telegraphs has to have certain standard just to make sure that it works properly. So they are not very highly defined standards as nowadays, but there were some standards so that the Morse code would work. So in 1861, the first coast-to-coast telegraph was laid, and in 1866, the first transatlantic telegraph, which means that it is connecting between United States and I believe United Kingdom, was built. So that actually allow intercontinental communication. In 1876, A.G. Bell developed the first telephone. That's the Bell Laboratories. That's the beginning of the Bell Laboratories. In 1878, the first commercial telephone exchange was built. Again, that also helped create modern day structured cabling. In 1904, 3 million telephones in the USA. That is a big jump of number of users. So it continuously grew from 1876 to 1904 up to 3 million telephone users in the USA. In 1915, the first coast-to-coast telephone line was laid, and again that involved cabling. And in 1930s, electronic television was developed and commercialized. In other words, in 1930s, the end users, like home users, start getting those televisions, right? Television sets. In 1947, 44,000 televisions were to be found in USA. That's the milestone. And in 1950, 10 million televisions in the USA. So within about few years, between 1947 to 1950, the electronic industry start picking up, especially with these televisions in the United States. In 1956, the first transatlantic telephone line was created. It's called the TAT-1. It has 36 channels. I believe, again, it is between the United States and the UK. In 1963, the first satellite relayed telephone connection was developed. And in 1969, ARPANET, which is the first WAN network, was developed by DARPA, which is the Defense Military Research Institute in the United States. And I think this is a very important milestone for network engineering and structured cabling in IT infrastructure. In 1986, development of the WAN network. So this would consider as the world's first wide area network, and this is probably the pretty much the turning point in modern day, networking infrastructure, including the modern day Cisco infrastructures that I have discussed in my CCNA lecture series previously on my YouTube channel. So in 1973, the first cellular telephone was developed. Why is it actually important to structured cabling when cell phones don't use cables at all? Well, because cell phones do use structured cabling, it's just the end user don't see them. For example, all those cell towers that you see around actually have certain structured cabling standards that we use to mount those, those antennas, and that will allow the end user to connect wirelessly. So even though the cell phone is not really building on top of the existing structured cabling standard, they actually help build many structured cabling standards as well, because as those the towers has to go somewhere, as well as cell communication still need some telecommunication exchange infrastructure that require physical cabling. So that the growth of cell phone industry did contribute a lot to structured cabling, modern day structured cabling. In 1984, the longest voice fiber optic line in the world was laid, and that honor actually goes to Canada. It happened in Saskatchewan, and it was 3,268 kilometers long. That would be the first voice fiber optic or optical fiber cable that was done, which was in 1984. In 1990, elimination of party telephone lines in rural Saskatchewan was done. In 1981, IBM PC and MS-DOS introduced. So that's another turning point in modern day IT network cabling infrastructure, because this is where that the personal computers and MS-DOS become a very, very important factor in how cabling standard will be defined to the end users, because it's not only IBM PCs used by industries and corporations, but slowly since 1981 the PC has gained popularity among the consumer markets. In 1985, the so-called the Ethernet standard was developed, which is the standard even we still use today, that allow the structured cabling industry and structured cabling methodologies to expand more into other areas, such as basically the home users with multiple computers. In 1991, structured cabling standards in America was kind of ratified at that point. Actually, that's a turning point, allowing the standardization of all cable management systems across the board. In 1995, the internet commercialized and become available to everyone. Now the structured cabling in the IT industry become more important than ever before after the 1995 commercialization. So what are the importance of the US telecom industry? A lot of people who never studied structured cabling or IT probably don't know about it, but if you've been in the IT industry, have heard about AT&T and Bell's subsidiaries, right? So the invention of telephone put the foundation of the modern day network cabling infrastructure and standards, and the invention of telephone and their telecommunication telecommunication cabling standards were actually introduced by the American AT&T and its Bell subsidiaries, because they play a major role in how structured cabling and related equipments were deployed in the 1900s for their telecommunication systems. So AT&T and Bell monopoly help build some of the modern standards even today. We use it because of their standardization happened in the early 1900s. So when I say the standards of AT&T and Bell monopoly, what I mean is that AT&T and Bell have their own way of doing cabling, and because they are such a big organization, it became the standard in many situations. So basically, AT&T and Bell came up with a cabling standards, and they use it everywhere across the continental United States. And then they also actually imported these ideas to South Asian and East Asian countries as well. As a result, and also Europe too. As a result, AT&T and Bell, their own methodologies become standards. That's what I meant by like the monopoly help build some standard, because they're such a big company. When they come up with an idea, and that idea usually become the standard for many things. Eventually, they allow smaller communication companies to connect to their network across the United States. But in 1960s and 1970s, the issue went to the court of having a monopoly over what is considered as a standard, how the structure should be built. And as a result, to create a new competition in the new data communication market in the 1984, the United States deregulated the industry, hence basically breaking apart the AT&T and Bell monopoly. So let's look at the deregulation from the history point of view. In the 1984, the industry was deregulated, hoping to create competition, right? That's the main goal. AT&T and Bell large infrastructure means that the structured cabling and related equipment work in tandem. So in other words, that because of their monopoly, even with the regulations, because of they are creating all the equipment and the large infrastructure, most of the related equipment just work in tandem. So there is no conflict between the equipment and the structured cabling, because both are done by the same company, AT&T and Bell, right? But right after deregulation, no centralized body means we are going to run into problems, and that's what exactly happened. Because reason for that is, I as a company can create a certain cabling systems, and then you as a equipment supplier can create an equipment that may or may not work with my cabling standards, right? So that's where the issue start to pop up, because now the AT&T Bell monopoly is gone. We have no centralized body defining how my structured cabling infrastructure should work with your equipment that you manufacture independent of me, right? So anyone can design and install and maintain telephones and network systems. This creates mass confusion, and multiple vendors came up with many different standards, and therefore there are so many standards that again there is conflicts and confusion, and interoperability is not taken into account as the technology was growing too quickly and more companies joined the race. So now we have a whole bunch of problems as a result of deregulation. So how did we solve these things? As the time goes through, we came up with some standardization bodies, and they actually help build those standards back up again so that everybody is on the same page. So we will discuss that in the next few slides. So government versus private industries. Telecommunication systems were regulated by governments such as the US government for a period of time prior to deregulation, right? So this, however, did not result in setting technical standards, because a lot of people think the regulations that the US government had prior to deregulation have set standards that may be like strong enough that it'll carry over to deregulated market, but that didn't happen. So the large companies like AT&T created their own standards and proceed to meet the government regulations, rather than the government saying, yeah, we're going to go with that standard and that's going to be standard for everybody. It just government came up with the regulations and AT&T just meet those regulations. An example of this would be if you have a microwave tower, how much microwave can be emitted into the space. Right, maybe regulated by the US Health Services as well as US FCC, for example. And AT&T will come up with a standard that will meet those guidelines, but doesn't necessarily mean that's a standard that every other company going to use. So that's what I mean by that. So there are regulations, and the AT&T is meeting those regulations. Otherwise, they can operate in the United States. But those regulations, are met with different standards that may not be followed by other organizations. So TSP, which is a telecommunications service priority, which is a service related request, and BSP is a Bell system practice, which is a documented practice. As NTP stand for notice to proceed, which is also a documented practice. So all of these hundreds of documents, small pieces of documents start popping up from AT&T, Bell, and with these large players, and that will define how their employees and their service providers should operate in this deregulated market. But that's not really widely accepted worldwide, especially not outside the United States. For example, most people never even heard about Bell System Practice or Notice to Proceed or Telecommunication Service Priorities, because TSP, BSP, and NTP are mostly North American standards. So now they are not even standard. They are actually, this is how we do at AT&T, this is how we do at Bell, right? But most of the small players had to follow these rules because they had no other choice, or they can't make a big impact on the market to have those standards change. So these standards doesn't mean they're perfect, and certainly not perfect at all, because these are all came up with these companies like AT&T. So the smaller companies and end users had no control over these standards or procedures. So if there is a problem with the TSP, BSP, or NTP, and unless otherwise the AT&T act on it, there's nothing the smaller players or the end user can do. Maybe there are issues with how good the quality of the signal is, but doesn't matter, because there's no centralized body or an independent body that can govern the changes to those TSPs, BSP, and NTP. So therefore, there's no power to the end user or the smaller companies with these kind of issues. So they met the government regulations, but it doesn't mean that the standards are good and the standards are followed by everybody. So this is the issue right now. So the reach of AT&T and Bell worldwide also is another thing that a lot of people don't think about. The AT&T and Bell arbitrary standards and procedures did not just impact the US local market, even though it just impacted the US local market initially. Countries like Japan, India, others have also adapted the AT&T and Bell created standards and procedures. They do this because, like, you might ask, like, why would anybody, like, why would Japan, why would India, out of all the countries, like especially Japan with all the developed technologies, why would they actually want to adapt AT&T and Bell arbitrary standards from the United States? Because they were using AT&T and Bell equipment, or companies like NEC in Japan use the AT&T and Bell technical documentations to build their own cables and cabling equipment. Why? Well, because it's cheaper and it is easier at that time. It is much easier for NEC, which is Nippon Electronic Council, I believe, from Japan, to just follow the AT&T and Bell lead than to reinvent the wheel. So they basically follow that. And why countries like India, Sri Lanka, those countries, those third world countries that are with emerging technologies, jump on AT&T and Bell standards, is because, again, it cut cost. And also sometimes the AT&T and Bell went to these third world countries such as India and Sri Lanka and donated their equipment. They're literally giving equipment for free. Why? Because then they can hook on you to go with their standards and then can sell their product later, like other products later. So the basic backbone infrastructure, for example, in India and Sri Lanka in the 1970s and 1980s, which my parents used to work with, is basically AT&T and Bell laboratory standards. Why? Because exactly, it's cheap. It's cheap, and some of the equipment are actually donated by the Bell and AT&T with the ulterior motive of selling additional equipment later down the road. So some of the old AT&T and Bell standards are still in use today, especially in India, Sri Lanka, those third world or poorer developing South Asian countries, as well as in African countries, also in Japan as well. Despite the outlook of Japan being a very cutting edge, sophisticated society, Japanese technologies and technological companies such as AT&T is very slow to react. So for example, Japanese NEC, they don't change many equipment very fast. They wait for evolution even instead of a revolution to change the equipment. So as a result, even in Japan, you still find all AT&T and Bell standard still in use. So after deregulation, the government still have some control over certain items, such as the use of transmission frequencies for cell phones and wireless equipment, auctioning of transmission frequencies. So who get to use what frequency? act as the mediator between industry competitors. So government agencies, not only in the United States but also around the world, act as the mediator between different telecommunication competitors and networking ISP, internet service provider competitors. So they actually work as, as a basically a legal framework for all their competition to happen. Health and safety considerations and regulations for ISPs and telecommunication providers also done by typically governments around the world. Some aspects of the industry research and development is also done, also considered as R&D, is done by government, especially military applications such as satellite tracking of fighter jets or intercontinental ballistic missiles, for example. Those are all military applications. Also, military do research on internet and other critical infrastructure as well, that later sometimes get released into the public. In fact, the modern day Ethernet and the WAN, wide area network, which evolved into the internet, was actually first created by DARPA, which is the American military engineering research facilities, right? So anything critical infrastructure also doesn't necessarily has to be military, maybe done research done by government. Like, for example, no government in the world want to see their entire communication structure goes down, right? For example, government of Canada or the government of United States would have their some kind of a backup plans, even though recently that Canada had a huge outage of communication systems thanks to the Rogers communication networks going down. But that does happen, when the private company communication network goes down. If the government is using it as their backbone, it might go down, but the government still pour money into research and development to help support those private industries to maintain and manage those critical infrastructure. So military applications and critical infrastructure, like the entire country's internet, for example, maybe have a lot of control through the government. When it comes by not so democratic countries such as China or North Korea, governments certainly have control over every infrastructure associated with not only structured cabling, information technology and telecommunication, but also every aspect of user experience. Some governments may have more control, therefore, over the other governments. Like, for example, even in China, however, even with this kind of more control, there is some limitations what the Chinese government can do. Like, for example, there are a lot of Chinese people who use VPN to connect to Western sites, media sites, and even upload information from inside China. And there's little control over the China's Great Firewall can do, because there are certain ways to circumvent those things. I will do a series of lectures on ethical hacking and exploitation of networking and IT critical infrastructure, as well as some some ethical hacking techniques on a later different lecture series. But so even if the government full control, like Chinese government, it's not perfect control. There is some ability to room to wiggle through those punch holes in those government controls. So governments still have control over certain things, but not most of the things that they used to have, especially in the Western civilizations. I just noticed something. I wrote deregulation here with a deregulation, but in here I put a dash in the between. It doesn't really matter. It's the same thing I'm talking about. So after deregulation, any company, private, public, can offer telecom services. So we need third-party non-governmental organizations to help us create cabling standards, because if we don't do that, what's going to happen is structured cabling standards going to be all over the place, and interoperability going to be an issue, and our customers and end users going to be frustrated, and it actually hinders the progress of innovation. It's going to hinder the growth of innovation as a result of it. So because any company, private or public, can create this telecommunication system as a result of deregulation, we need to have some organizations to step in. So from telecom to the data networks, if you look at from the historical point of view, late 1970s to mid 1980s, there was a rapid growth of PC-based networks. Popularity of mainframe systems got really took hold in major companies, corporations, and governments. IBM, even today, as of 2022, play a major role in the popularity of mainframe system. IBM is the main equipment and service provider for majority of mainframe systems in North America and worldwide. Like for example, government of Canada, government of the United States, the government of India still use the IBM mainframe systems. In the late 1980s, the systems with own vendor specific software came about. I will discuss a little bit about why software is important for hardware as well, because some of the cabling standards were changed because of the software needs that to be changed, and the cabling types and structure start to become very convoluted. For example, IBM would have a different type than the HP, and the HP have a different type than Apple, and everybody else will have different types. In the late 1980s, it was a freaking mess. So messy data network cabling. So mainframe and PC based cabling was a mess, as each manufacturer had their own proprietary standards. This is supposed to say proprietary, not prosperity, sorry about that. So as many people having many different proprietary standards, we will have multiple different standards. Even today we have this issue. For example, Apple would not use the USB-C standards on their iPhones. Everybody else tried to use USB-C standard, but Apple have, I believe, lightning cable or something like that. As a result, that Apple has their own proprietary standard. And Apple being just like AT&T in the past, being such a big company with lots of iPhone users worldwide globally, Apple can do that because they have lots of customers worldwide, and Apple can stick it to USB-C global standard and then force their customers to use their own proprietary cabling standards. Now, just like the United States in the past, the governments in European Union trying to step in and force the Apple to use USB-C standards, and that may help eliminate this issue. But the thing is, that shows that even in modern day, not in the 1960s and 70s with the AT&T, but even in 2022, large companies like Apple can force their customers or end users to use certain standards. So having their own proprietary standards can become a headache for end users, customers, and IT technicians. So in the past, for example, in IBM 3270, we had RG62 coax, BNC, IBM System 3X had Tunex cabling, and the IBM STP token ring. And these are some different cabling standards. So as you can see, these are some of them shown here in this slide. So like those are becoming very complex, right? Confusing. So IBM 3270, I believe this one, and the System 3X is this one, and the IBM STP token ring is this one. But see, even within IBM, the cabling methods changes, the cabling connections changes from their system to system. The other ones include the DCE, which is a shielded low cap. It's called RC232 cabling. That looks like this. With Apple and ArcNet came up with the RG58AU or RG62U coax cables that I believe look like this. Then IBM PC came with the ThinkNet and ThinkNet coax cables. WAN cables, those are, I believe, IBM WAN cables. Those are RG59 twin coax, and then we have a whole bunch of other things, then the list goes on. So you probably never seen something like this, but again, there's another way of connecting, splicing cables, and all of those things happen because there is no regulation or standards. So as I mentioned briefly before, the cabling standard has, hardware and cabling standard has to do with the hardware equipment itself and hardware evolution of hardware, but the different types of cabling and equipment standard by different companies is also driven by changes to its software. So changes in software or the improvement to how the software works are also often force the end users and the companies to upgrade their hardware as a result. So hardware upgrades are not necessarily an improvement to hardware itself, but maybe how the software is processing information. For example, IBM mainframe went through multiple iteration of software changes with the COBOL infrastructure. COBOL is a really old programming language that's still used in mainframe IBMs by multiple governments around the world and big banks. Like for example, Royal Bank of Canada still have a IBM COBOL mainframe. Government of Canada still use the IBM COBOL mainframe, and many other organizations. So as a result, this IBM mainframe does play a major role in what software will be used. And if the COBOL software needs a specific cabling structure or specific hardware, guess what? That's what the hardware going to be. So how software interact with the hardware also did play in how hardware evolved over time. Why weren't the standardization practices implemented sooner? At this point, one of the major reason is that it made money for some industries. For example, if you are the IBM, you can sell the IBM proprietary equipment, IBM proprietary software, IBM proprietary cabling, IBM proprietary everything, and then it make money for IBM. As from a cabling point of view, if you are a cabling manufacturer, if every single time an organization or an entity change their mainframe equipment and all the other equipment, and they have to put new cabling in, again, that make money for the cabling industry. So as a result, the standards weren't implemented sooner. Basically, you can mix and match, right? So that's why. So let's learn about the balun impact on standards. A basic device called a balun, also known as balance and unbalance, that's where the balun come from. So balun came from balance, unbalance, and impacted the direction of vendor specific cabling. So this is a simple device, essentially an electronics transformer converts between a basic telephone cable called UTP, which is the unshielded twisted pair, and a coax cable. So basically these baluns were used between the UTP cable and the coax cable, because UTP cables are considered as a balanced cable and the coax cables are considered as an unbalanced cable. Why is it called balance and unbalanced? We are not going to go into detail right now here to keep this lecture short, but just know the balun is basically stand for balance, unbalance. It's a device like this where one side will have one type of connection and the other type will have another type of cable connection. So what it allow is connecting different media together. So that's what the balun going to do. The baluns were used in the late 1980s as a solution to recabling cost and eventually accepted as a standard practice. In other words, instead of recabling the whole system, the whole area with the entire structured cabling pulled out and put a brand new one, you can now use these baluns to connect new equipment or different equipment at the end of a currently existing structured cabling infrastructure, because that will convert from whatever one end to the whatever another end. The baluns allow cable installers to install inexpensive UTP telecom cables on site and then use appropriate specific type of balun on each end to emulate system specific cable requirements. So even if you are installing a brand new cable structure, you can use a cheaper cable type such as the telecom cables for the entire structure on site, and then just use a balun at the end to hook up a new type of equipment, right? That cut down the cost. The use of baluns means that the system changes do not always result in change of entire structured cabling infrastructure. And we still use baluns today. For example, these are modern day baluns that are being used on a CCTV system, where CCTV cables are coax, but the final connection of the CCTV onto the equipment is not coaxial. In that case, you can use a balun like this, and they still use today in, like, even companies like Walmart, right? Walmart CCTV system is pretty old actually. They don't use the modern day CCTV because it's cost cutting thing, right? They still have the CCTV, but they use baluns like these ones to make it work. So it's balance stand for balance unbalanced. So basically it connect two different types of cabling structures. Fast Ethernet hub. So Synaptics offered an Ethernet hub in the mid 1980s. This is a crucial turning point for structured cabling, IT industry and network infrastructure, because direct connection of UTP without external balance using RJ45 modular plug was first introduced by this particular Synaptic hub. So technically the hub has internal balance for each port. So in other words, having these external balance like these balance are already integrated into this switch port in here. So it's a physical balance is inside the switch box. In other words, inside the hub. So it created this universal structure for cabling. So now as a structured cabling technician or an engineer, only thing you need to care about is the cable and this end only. You don't have to care about the balance or connecting anything, because it's all done by this box. So this is used as the first Ethernet hub in the 1980s, and as a result that what this hub has created is what we call the star network topological structure. So this is a structure that used everywhere, even in 2022, even in many infrastructure projects, in network infrastructure projects all over the world, as well as in households. Basically, if you have a network switch or a router, because nowadays we don't use hub anymore. I'm not going to go into detail on what's the difference between a switch, hub and a router. That's a complete different thing. It's nothing to do with structured cabling. I already have discussed that in CCNA lectures. If you're interested, please check out my YouTube videos on those ones. But basically, if you are using a switch or a router, which is the modern day equipment we use today, that is basically have balance on every single one of those switch port that you are connecting to. They have built-in internal balance. So the balance had a huge impact on modern day Ethernet switches and routers, which started with the Ethernet hub that was introduced by Synaptics in the 1980s that contained internal balance. So you only care about the connection point and how you connect. You don't care about the conversion of different media, right? Because it's all done by this switch, the hub, right? So after the first hub was introducing to the market, the idea of internal balance as opposed to external balance become a very popular idea. So the UTP network interface cards, the company started manufacturing network interface cards as opposed to balance that already contain that component, and more companies start introducing hubs, and the hubs allow different data or data network types to interact with each other. And with the final step before this would be the final step before global standard for Ethernet was developed. So balance had a huge impact on how the modern day networking infrastructure work. Standardization. Still, there were no standards on signals used, the data rates, or for even cable manufacturing. So we have the balance already built into the hubs and switches and routers, but it's still not really standardized at this point. What it does actually basically removing that particular external component, right? So as a result, the multiple manufacturers introduced their own cabling standards, and one of those companies called the Anixter in the 1980s. And they introduced something called the levels or grades or categorization of various cables. So basically they introduced this thing called levels or grades, and that basically categorize their own cables based on the performance of those cables. So this is basically really important, because in the 1980s what Anixter pretty much did is taking the first step in standardization of cabling. So other manufacturers are also keen to come up with these kind of levels or categories or grades of cables, and this would lay the foundation for creating the vendor neutral cabling standards we use today, such as the Cat5e, Cat6 cables, for example. Those are all came about as a result of the Anixter first introducing these levels or grades of cabling based on their own cable manufacturer standards. So standardization organizations. The manufacturers look to create standard setting bodies. Those are called organizations or bodies. And structured cabling standard now dictated by or directed by TIA and ISO. TIA stand for the Telecommunications Industry Association, which is the North America standard body for structured cabling, and that is one of the first independent organizations to start setting standards. And the other one is called the International Organization for Standardization, also known as ISO. It is a collection of standards organizations that represent 130 countries. So it's not a one single organization per se. It's a collection of standard organizations within different countries working together to build standards. ISO goal is to establish international technological standards that facilitates the global exchange of information. So try to remove the barriers for global exchange of information by standardizing all of these items. TIA and ISO are not competing against each other. This is a very important key point that you need to understand if you're a student. A lot of people think the TIA, which is the Telecommunication Industry Association in North America, is competing against the International Organization for Standard, ISO. It is not. The TIA and ISOs are two different organizations, but they are trying to achieve the same goal. So the technical standards are different between the two, but similar in many other ways. So technical standard may be different between the two, but they are similar in many ways. So both state that the cabling system specified by them should exceed 10 years of useful life, for example. So even though they have two different standards for cabling, both agree that the cabling system specified by TIA and ISO should at least exceed the 10-year useful life. So if you buy a cable that is TIA or ISO standard, it should last for minimum 10 years of useful life. Why? Because both of these organizations agree that should be said. So they're not competing against each other. They are working with each other while trying to create their own standards. Therefore, the terminology, categorization, etc., may be slightly different between TIA and ISO, and sometimes the same between the TIA and ISO. So keep that in mind. The terminology, categorization, etc., may be, and in most cases different between TIA and ISO, but they are not competing. TIA is not competing against ISO. They are working together as friends, you know what I mean? So try to standardize everything. Other standardization organizations includes IEEE, it pronounced IEEE, so you pronounce I first and EEE, which is the Institution of Electrical and Electronics Engineers Association, which states standards for the electronics and computer industries. EIA, which is Electronics Industry Alliance, which made out of electronics manufacturers, and it sets the standard and help write ANSI standards. ANSI is basically American National Standard Institute that works with the EIA to write those standards. EIA becoming more and more important now as other organizations such as IEEE as the use of IoT devices. I believe most of the IoT devices are standardized by EIA standards and IEEE standard combination, not just IEEE standards. So if you have any IoT devices, Internet of Things, if you don't know what it is, you can quickly Google search it. I have covered that on my previous lectures, on my previous lecture series. So those IoT devices have IEEE EIA combination standards. ANSI is the American National Standard Institute, that is for the United States. CSA is the Canadian Standard Institute, again a Canadian Standard Association. Again, they are not competing against other people. They are trying to create their own standards within their own countries, just to make sure everything goes smoothly. The European Committee for Electro Technical Standardization is another organization. The International Communications Union, or ITU, is another one. The JSA and JSI, which is a Japanese standard association responsible for Japanese side of the equation. Again, JSA have very similar regulations as IEEE and technical standards IEEE, and the other two organizations I mentioned before, the TIA and ISO. So none of these organizations try to attack each other. They are trying to work together and try to just make sure that each of these regions and countries are represented properly. Computer communication standards. So computer communication standards were non-existent until 1985, when the CCIA, which is the Computer Communications Industry Association in the United States, approached the EIA, which is, remember, the EIA is the Electronic Industry Alliance, about developing a specific standard. And the resulting result of that is the TR41 committee. The TR41 committee was split into two in 1991, which is TR41 and TR42. The TR41 was responsible for user premise equipment standards, while the TR42 was responsible for the user premise telecommunications cabling infrastructure standards. And the TR42 is basically responsible for ensuring that the standards remain open system in supporting of the voice, data, video building, control, and other low voltage applications and power, low voltage, low power applications. So that's the result of the TR41 and TR42 two committees. AT&T set the technical, administrative, and performance standards for its infrastructure, remember, in the early days, because they are such a huge organization. And with the AT&T breakup, the vast infrastructure and a government that was unwilling to interfere with the free market, and the industry had to be fixed itself. So AT&T said the path to many of the today's communication standards, but as after deregulation, that the other organizations adapted some of the policies or all of the policies of AT&T. As a result, those become certain standards. Again, I will discuss that in my next lecture as well. Computer and data communication standards were established by market forces, primarily driven and defined by what customer wants and needs, desired of the manufacturers to satisfy their customers, and the requirements that the products can connect to existing infrastructure and other equipment, including competitors. So, for example, I can buy a Cisco switch and connect to a random Cat5e cable, and Cisco switch should not have any problem. I don't need to buy a Cisco cable, for example. I don't think Cisco even manufacture cable. I can buy a Cisco switch and connect to an IBM mainframe. In most cases, it will work fine. You just need to make sure the configuration is done right, such as VLAN and other things. Again, if you're interested in those networking engineering concepts, I have already covered that on a different lecture series on my YouTube channel. The impact of standards include that standards are specifications that guaranteed a minimum level of performance and are used to quantify and qualify materials and components. This is the definition of standards. On an exam, if you are a student taking engineering classes or technical classes, if your instructor asks you what is a standard, and if you repeat these words, standards are specifications that guarantees a minimum level of performance and are used to quantify and qualify materials and components, that should be 100% correct, valid answer, because that is the definition of a standard. Standards are independent. In other words, the user will only accept standards based products, and therefore the vendors compete on an even level because the user is looking for that standard. For example, a D-Link switch, a Linksys router, and a Cisco switch should be able to work together. They shouldn't have any issues because packet transmission standards are already done, right? So that's what it means. Standard have lots of advantages, which is ease of design, installation and maintenance. Performance guidelines and baseline requirements are met by all those independent manufacturers. Easier to train staff and provide moves added or changes to your network. Like for example, if you have an IT professional who is a Cisco expert, it would be very easy for that Cisco expert to transition into IBM switches and routers and mainframes for switching and routing, because Cisco networking infrastructure should be similar to that of IBM, because they are using the same packet transmission standards. Increased lifespan of the installation and universally accepted. So if you put cabling infrastructure, that should last for a long time, as the cabling infrastructure is built based on standards, and the newer equipment will follow those standards for the most part. So not always, but for the most part. Like for example, if you have cabling infrastructure that is on Cat5e, but you bought new equipment that can do like really high bandwidth in the local area network, you may have to upgrade into Cat6 cables, right? So it doesn't mean that the standard is bad. That means that standard have evolved into a next level. So your installation have an increased lifespan, but it happened to be like your organization decided to go to the higher tier cutting edge Cat6 cables because you need that higher bandwidth or throughput, right? So that's what that mean by that. So just because we have standard doesn't mean you don't need to change your structured cabling infrastructure. That's why we still train structured cabling technicians. That's why we still have networking engineers, because we still come up with new technologies, and as new technology evolves, as the certain things do change, but it still increase the lifespan, as opposed to having many other organizations throwing stuff into the wall with many different standards. The assurance of application operations, the cable and connectivity backward compatibility, the interoperability, as I mentioned, between the Cisco switch and the D-Link switch and the etc. The design and topology that are universally accepted, managing cable additions and upgrades and changes, defining a cable system that support current applications and is a basis for future development, are all positive impacts of standards. So standards will have a positive impact of all of these things. Again, I'm not going to go into detail in here because I already covered that on the previous slide. You can pause here if you want to read them, but these are some of the standard advantages of using standards. Standards and structured cabling systems. So standards in structured cabling system allow consistency within and in between sites. It allows installation of multi-vendor hardware, as I mentioned before, flexibility in cabling and equipment additions, removal, changes, and moves will be facilitated by these standards. Efficient troubleshooting procedures, because if you use a similar or standardized equipment across the board, the troubleshooting process from one side to the next is going to be the same. It doesn't matter the switch is provided by Cisco and the next switch is provided by IBM. The VLAN standard is going to be the same. How the transmission of data through that cable to the end user going to be the same. You can have a Cisco switch on one side and the IBM switch on the other side, and how you troubleshoot a problem with your end user on one side to the next side going to be the same. The support basic fundamental at the most fundamental level, the troubleshooting procedures are the same. How you go about troubleshooting may be different because Cisco switches have a different firmware compared to IBM switches, but the fundamental troubleshooting procedures are the same. Flexibility in expansion and modification of structured cabling infrastructure as technology changes with time is also another huge benefit, a positive to structured cabling standards. We're going to switch gear a little bit and we're going to talk about codes, regulations, and certain laws. So codes are basically, in the United States, the National Fire Protection Association, for example, NFPA, maintains the National Electrical Code, also known as NEC. And NEC specify where various types of cables can be used within a building and materials used in that build on those cables. And those NEC codes are being followed even in networking cables. And codes are basically like laws. Those are actually laws. Like in Canada, for example, there are two important Canadian codes we use. One called the National Fire Code of Canada, which is known for NFCC, and the Canadian Electrical Code, which is known as CEC. Again, NFCC and CEC are very similar, very close to that of the United States NFPA, NEC, but they are slightly different in a way that it is specific to Canada. So what the codes are is basically legal requirements. Codes are not standards, these are actually legal requirements. Standard may follow codes, some standard may not follow codes. So those are what we call codes. So when you are doing structured cabling, you need to look into codes as well. Regulations, on the other hand, are basically like codes. They are still legal requirements. However, that may be different from region to area. Like in countries like the United States and Canada, the regulations may slightly differ from state to state or province to province, even city to city. Different cities may have slightly different regulations. Regulations also include work safety or equipment safety rules when installing structured cabling. So if you go to the site and you start pulling cables everywhere, and there are certain regulations that you need to follow at each site depending on where you are in the country, in Canada or in the United States or in other nations, right? Site or client specific regulations are also important because there may be a client, let's say a big organization like such as University of Calgary. If you are a subcontractor for University of Calgary may have specific regulations on how you're gonna work on your structured cabling on University of Calgary sites. So that's what I mean by site or client specific regulations. Standard codes and regulations, they are similar, but they are not same. The TIA or EIA standards are optional, where the codes and regulations are legal requirements. As I mentioned before, some standard may follow exactly how the regulations or codes are written, but some standard do not follow that. Therefore, the EIA and TIA standards are optional, where the codes associated with structured cablings are legal regulatory requirements. Certain aspects and areas of data communication installations must be carried out by certified personnel such as electricians. This includes building grounds, electrical systems, and many other installation of conduits. Like for example, you are not allowed to put, in many areas in Canada, you are not allowed to put low voltage cable together with high voltage cable in the same chamber. So you can use the same conduit to put your Cat 5 or Cat 6 cables with the 240 volts or 110 volts cable. Why? Because it's in the codes or regulations for that area. There are situations where you need to also follow certain regional regulations that not in standard. Like for example, if you have a certain areas in Canada is prone to flooding, for example, and there are some codes and regulations done by city governments or local government that's saying that you cannot have electrical or electronics equipment rooms below ground. So that means you can't have a networking closet in a basement unless it absolutely have to. Then you need to get a special a bypass, a special consideration from the government to put that equipment. So when there is a new building, for example, in certain areas, the flood prone areas, you can put your networking room and server rooms in the basements as such. You can put all your electrical equipment in the basement as such, right? So those are, for example, that you need to follow based on where you are. All fire regulations must be followed. For instance, the cable must meet a certain standard for combustion, but those standards may be different, or those codes may be different from region to region and how you install it. Like for example, in Canada, there may be a law, I'm just saying, like I don't know whether there is a law saying that the cabling for any networking equipment has to meet this kind of fire rating under this condition, but the same rule may be different in, let's say, United Kingdom or in Germany. maybe in Germany, you can use a little bit lower grade or a little bit higher grade. So depending on where you work, you need to read up on those standards and codes. And certainly do not perform anything that you are not certified to do. If you're not sure, you should ask from your supervisor or the company that you're working with. For example, certified electrician should do certain work that a certified cable installer should not be working on. But in some countries, a certified cable installer will also have certification to install electrical equipment as well. So if you want an electrical outlet to put a server or a networking switch or a cable distribution point, in some countries, you may have the certification to do that even as a cable installer. But in Canada, it has to be done by an electrician. A cable installer can do that unless the same cable installer is certified as an electrician as well. So you need to think about that as well. Keep in mind, codes and regulations are not something that you just use whenever you like to and not ignore whenever you don't want to. Codes and regulations always take precedence over standards in every country in the world. Every country in the world, even in third world countries, codes and regulations always take precedence over any standard or international standards you use. As I mentioned before, a country may use the international standards as a guidelines for their codes and regulations and stick to it exactly as it is, but it may not, or it may add up more stuff or remove certain things. So at the end of the day, codes and regulations always take precedence over standards in every country. However, if the standards exceed the requirements for the codes and the regulations, then you're good to use those standards and move forward with your project. So codes and regulations take precedence, and standards has to either meet or exceed the codes and regulations always, regardless of the country where you are doing cable installation. So that's everything for our first lecture. If you like these kind of lectures, please make sure to thumbs up this video and subscribe to my channel. Until our next lecture, thank you so much and have a nice day.